Okay, so you're using AI agents in your company. But how do you know if they're actually doing well? How do you evaluate the performance of your AI agents? Are they actually doing what they're supposed to do? And where do they stand in performance compared to their human counterparts? To do this, you need to observe every step that the AI agent takes. For an AI agent that automates customer-facing conversation, you need to observe every step in the course of the conversation with the users. As part of this conversation, AI agents do several things. Call the LLM with the user's message as question or request. Identify the tools to call with corresponding tool input. Actually call the tool with the input and get results. The LLM takes the tool output and decides the next step. This keeps going in a loop until the user's request is fulfilled, and then the user sends another message and tries again. This is called the agent loop. As part of this agent loop, one important tool the agent needs to call is the knowledge retrieval tool to get the relevant knowledge text snippets from the documents in the knowledge base. And it's super important that the results of these knowledge retrieval tools are of high quality, accurate, relevant, and complete. If we want to do agent evaluation, an important part of that is knowledge retrieval evaluation, which is what we're going to discuss in this video. We'll cover other aspects of agent evaluation in future videos. Knowledge retrieval evaluation is exactly what it sounds like. A system that tests or evaluates the quality of your knowledge retrieval. So, why does that need a whole system? I'm sure you've heard about RAG. Agentic search is gaining a lot of popularity, and there's the good old full-text search with all its variants. Combine these and more, and you get a universal set of retrievers. Here's a chart of 24 different types I've curated. There can be many more. They all follow a four-step pipeline: index, query manipulation, search, search refinement. We'll cover the details in a separate video focused on retrievers. Each retriever is just a tool to fetch the right information from your documents for a given query. So let's say you've configured 3 different retrievers on the same knowledge base. If you want to know which one works best for your users' questions, you need an evaluation system. Why do you want to know which retriever is best? Why does this even matter? Because you want to give the most accurate, relevant, and complete information to your users when they ask about your products or services. Inaccurate, irrelevant, or incomplete answers erode user trust the way hair leaves a balding man's head. Gradually, then all at once. And in finance or healthcare, giving wrong information isn't just a trust issue. It's a compliance issue. What is the definition of best? I'm defining good knowledge retrieval on 3 axes. 1. Accuracy. The information is accurate and factual. 2. Relevance. It's relevant to the question. 3. Completeness. The information is taken fully and exhaustively from all the documents in the KB. How do we calculate these 3? Well, accuracy is always 100%, as long as the documents in your knowledge base have correct information. Why? Because the retriever returns text excerpts directly from those documents, nothing outside it. So accuracy isn't really the variable here. The interesting questions are relevance and completeness. To calculate relevance and completeness, we compare 2 things. First, the retrieved chunks, text snippets the retriever gives us for a query. Second, the ground truth chunks, the actual snippets that hold the answer. Then we calculate 2 values. Recall, how much of the ground truth was included in the retriever's results? If all of it, recall, is 100%. If half, 50%. So recall is just completeness, formalized. Precision is the opposite question. Out of all the snippets the retriever returned, how much was actually relevant and how much was just irrelevant garbage? If everything returned was relevant, precision is 100%. If half was relevant, 50%. So precision is just relevance, formalized. So now we know what good retrieval looks like and how to measure it. Next, how to calculate recall and precision in a way that scales across retrievers. Most teams measure recall and precision by matching against specific chunks. Each chunk gets an ID: chunk 1, chunk 2, chunk 3. The ground truth is just the list of chunk IDs that should be returned for a given question. Manually labeled, slow but accurate. Match retrieved IDs to ground truth IDs, compute the score, done. But here's the catch. Switch to a different retriever, one that chunks the document differently. Now chunk mark 3 points to completely different content. Your ground truth labels are useless. They were anchored to a chunking strategy you no longer have. So testing each new retriever means redoing the entire ground truth dataset. It's like saying, I'll have the number 23 doors, and then the menu gets reorganized. Now number 23 is a salad you didn't want, and you have to redo this for every retriever you test. 24 different times. Manual, slow, expensive. I was reading about this problem and came across this amazing research done by the Chroma team. They published a paper called Evaluating Chunking Strategies for Retrieval, and it changed how I think about this entire problem. Instead of evaluating at the chunk level, evaluate at the span level. Character spans, anchored to the document, not to any chunking strategy. Here's how it works. Every document has character positions, 0, 1, 2, all the way to the end. The ground truth for a question becomes one or more character spans, each with a start index and an end index. Think yellow highlighter dragged across the page to mark where the answer lives. It's the difference between page 47 and page 47, second paragraph, third sentence. Both find it. One is way more precise, and the chunking strategy doesn't matter. The ground truth is anchored to the document itself. Now we have one golden dataset. Character spans, fixed to the document. Run any retriever you want. As long as it returns chunks with their start and end positions, we can compute recall and precision against the same ground truth. 24 retrievers, one dataset, apples to apples. So that's the move. Build your golden dataset once with character spans. Track positions on your retriever chunks. Then test as many retrievers as you want and let the data tell you which one wins. Quick recap, 3 things we covered. 1, every customer-facing AI agent needs evaluation, and knowledge retrieval is at the heart of it. 2, what makes retrieval good? Accurate, relevant, complete. Recall and precision give us the numbers. And 3, chunk-based evaluation breaks when chunking changes. Span-based evaluation with character spans lets one golden dataset work across any retriever you throw at it. Now you've got the foundation. Next up, we can take a bunch of different retrievers and a single golden dataset on a knowledge base and check how each retriever performs. That'll be in a future video. Until then, thanks for watching. Please like the video and subscribe to my channel for more updates on building CX AI agents.